right, so this lesson is 3-7. We're solving for absolute value inequalities. All right, so let's talk about that. We are given an equation like this. Which reads the absolute value of x minus 1 is going to be less than or equal to 2. Well, we all know that the absolute value means that it has to be positive, but how do we know what's positive? We don't even know what x is. So what I'm going to do is, for one of the equations, I'm going to keep just like this. I'm going to put this one over here. X minus 1, taking it out of the absolute value bars, and going to solve it just as is. Now on the other one, I'm going to do x minus 1. I'm going to flip my inequality around, and instead of a positive 2, I'm going to go ahead and make it a negative 2. This way I can find my minimum and my maximum. All right. To get the variable by itself here, I'm going to add 1. The 1's cancel. My x comes down. My inequality comes down. And I get negative 2 plus 1 is negative 1. So this reads that x is going to be negative 1 or more. Now let's do this one. Again, we're going to add 1. These cancel. X falls down. My inequality falls down, and 2 plus 1 gives me 3. This is known as my minimum and my maximum. I have a minimum of negative 1 and a maximum of 3. So when I go to put this on a number line, I have a negative 1. Let's just put 0 here. And let's go ahead and put 3 over here. What this is telling me is that x is bigger or equal to negative 1. So that means I get a solid dot here. And it's going to be bigger, which means I'm going to go in that direction. But x is less than or equal to 3. So I'm going to put a solid dot here, and this line's going to go in that direction, which means the range is between these two numbers, giving you your minimum and your maximum. All right, let's try another one. Okay, we have 2 times the absolute value of x less than or equal to 6. All right, so to kind of take the 2 steps that I did before and combine them here, I'm just going to go ahead and divide this whole thing by 2 to get that absolute value x by itself. My 2's cancel, and I get the absolute value of x is less than or equal to 3. Now, because an absolute value could be a negative in here, it could also be a positive in here. We're not real sure. So we're going to say that x, flip the sign around, to negative 3 is greater than or equal to negative 3, and x, keeping the sign in the same direction, is less than or equal to 3. So what you're going to do is flip the sign, change the integer from in its inverse. So if it was negative here, a negative integer, you'd make it a positive, and then one of them is going to stay exactly how it's laid out. Let's make our number line. This reads that x has to be larger or equal to negative 3. So let's put negative 3 on here. And this one reads that x has to be 3 or smaller. These are both equal to's, which means that the answer falls between these 2 integers. All right, let's try another one. The absolute value of x plus 3 minus 4.5 less than or equal to 7.5. All right, first thing we're going to do is go ahead and add 4.5 to each side. Let's just go ahead and get that out of the way right now. Combine those like terms. These cancel. The absolute value of x plus 3 falls down, keeping them in the absolute value bars. Bring your inequality down exactly how it is. And 7.5 plus 4.5 is going to give us 12. All right, now if you remember in the previous example, we're going to do this twice, which means one of them's going to stay exactly how it is, and the other one we're going to change. So we have x plus 3. The beginning part always stays. The inequality flips, and the other answer becomes its inverse. And in this case, it's going to become a negative 12. All right, let's get that variable by itself. So here we're going to subtract 3. This cancels. And x is less than or equal to 9. Now let's do this side. Subtract 3. And this says that x is going to be greater than or equal to negative 15. So when we go to make our number line, this says that x has to be 9 or less, but x also has to be negative 15 or higher. So I'm going to put down here negative 15, 0, and 9 just to show the progression. Okay, let's do the first one. We have equal to 9 or less, going in that direction. This one here is negative 15 or more, which means these two have a range in the middle. All right, let's try another one. So as you're noticing here, because it's absolute value means the answer could be positive or negative inside that absolute value bar. The variable could be. So because of that, we have to put down both of those options. All right, so here we go. First thing let's do is combine like terms. So I'm going to go ahead and take the inverse of positive 14, which is negative 14. Do that to both sides. My 14's cancel, giving me the absolute value of x greater than or equal to 5. All right, now there's really nothing to do here. X is already by itself, but because we're not sure if absolute value, if the variable is positive or negative in there, means that we're going to go ahead and put one exactly how it is now, and the other one, we're going to flip the sign around and make this the inverse. So inverse of positive 5 is negative 5. So let's fill in our timeline. This says that x has to be bigger than 5, but smaller than negative 5. This one sounds like it's going to be a split. So this is going to be an OR. So we have x is 5, so let's go ahead and put 0 here. And I'll put 5 over here and negative 5 over here. Now let's just do what it says. We can both know, or we can see that these are both equal to, so they're both going to get solid dots. Now we just have to figure out what direction they're going in. So x has to be bigger than 5. Okay? But x has to be smaller than negative 5. Oh, so you see the gap we have here. That's why it's an OR. Let's try another one. 3 plus the absolute value of x plus 2 greater than 5. Again, let's go ahead and combine like terms. This is a positive 3, so I'm going to make it a negative 3. Okay, these 3's cancel, giving me the absolute value of x plus 2 greater than 2. All right, let's put our two options down. The first option they gave us, so we'll go ahead and keep that, x plus 2 greater than 2, and in this case, or x plus 2 less than negative 2. Again, taking the inverse here of that positive 2. All right, let's get the x by itself. We're going to subtract 2. And this is x is greater than 0, or, and you'll know it's or because when you graph it, they don't overlap. They go in two opposite directions. All right, so we get negative 4 there. So let's go ahead and graph this, and I'll show you what I mean. This one here says that x has to be bigger than 0. So I'm going to go ahead and put 0 here and negative 4 here. Still sticking with a standard number line there. All right, so x has to be bigger than 0. It's not equal to, so I'm keeping the circle open, has to be bigger than 0. This one says that x is smaller than negative 4. Smaller meaning going away from 0. It's not equal to, so it gets an open circle. And that's what creates your OR when they split like that. All right, last one. We have the absolute value of x plus 10 greater than or equal to 12. All right, let's go ahead and combine like terms. So we're going to subtract that 10. The 10's cancel, and I get the absolute value of x is greater than or equal to 2. Now, since I don't have to get x by itself, it's already there, I know that we have x is greater than or equal to 2, exactly how it's written, and its inverse, flipping everything around. Let's graph that. We need a 2, and we need a negative 2. They're both closed circle. All right, this reads that x has to be bigger than 2, but smaller than negative 2. All right, hopefully that helps you tonight.